For our chemically speaking work today, we're going to look at the learning intention I will understand precipitation reactions. So we should be able, by the time we finish this, to define precipitation as a chemical reaction, so not confusing it with rain or snow, explain how the atoms rearrange, and write equations for precipitation reactions. So let's have a look at precipitation reaction rearrangement of atoms. You can see from this little diagram that it's a double displacement. In other words, when we take a reactant and another reactant, we're actually going to swap partners. Both of them are going to swap partners. So A now combines with D, and B joins up with C. What's interesting about precipitation reactions is whether things dissolve or not. So in a precipitation reaction, the things that dissolve in water are the reactants. So these are solutions, as well as one of the products. And the other product does not dissolve in water. So this is where our solid comes from. That is our precipitate. And this is what causes the reaction mixture to become cloudy. Let's look at an example. In this precipitation reaction, we have two colourless solutions reacting, and the instant that they react, they make an insoluble solid. What we use for showing this is the letters AQ. That stands for aqueous solution. So you can see three of the things in this equation are aqueous solutions, and one is denoted by a little S in brackets, which stands for solid. So in this equation, silver nitrate and sodium chloride are both colourless solutions, and they form a precipitate of silver chloride, floating around in sodium nitrate, which is another colourless solution. But how do you know which of the products is going to be insoluble? Well, we need some rules. So here are our solubility rules, and you'll see that we've got some things that are always soluble with a few exceptions. So we've got all these things that are soluble, but we've got a few exceptions, and the exceptions include things like all chlorides are soluble except silver or lead chloride. Similarly with iodides, all iodides are soluble except silver and lead. Sulfates are all soluble except for barium, lead, and calcium sulfate. And if we flip this around, all hydroxides and carbonates are insoluble except for a couple of exceptions there. So except for potassium and sodium hydroxide or carbonate. So those are our rules, and we don't need to memorize those. We've always got access to a solubility rules table. So let's have a look at another example and see if we can apply our rules. In this example, we've got cobalt chloride, which is the coloured liquid in the background, but it's a solution. Reacting with sodium hydroxide, that's being dropped in with a pipette that we can't quite see in the image. And the moment that they react, you get a blue precipitate. So the question is, what is the blue precipitate? So we have a little bit of a look at the equation, and we've got some options. Remember, it's double displacement. So the cobalt is going to swap partners with the sodium, and it's going to become cobalt hydroxide, and the sodium is going to pick up the chloride. So have a look at the solubility table. You should be able to predict what the precipitate will be. So pause the video, have a look at the solubility rules from the previous slide, and see if you can work out what that precipitate is. So hopefully you worked out that it's going to need to be something that does not dissolve. And if we look here at the hydroxides, all hydroxides are insoluble except potassium and sodium. We were making cobalt hydroxide. So cobalt hydroxide would be insoluble. That would be our precipitate. So I think we have covered all our success criteria. We know that precipitation is the formation of an insoluble solid from some solutions. We've shown how the atoms swap partners in a double displacement rearrangement, and we've looked at writing some equations for those precipitation reactions.